I have recently switched to 4S batteries from 3S, and along with that, I switched from 6-inch to 5-inch props, and I swapped my Sunny Sky motors, the Sunny Sky 2204 or 2300 kV motor. Some people reported that it wasn't entirely happy on 4S, that it had a tendency to throw magnets, and also I was crashing and breaking them way too often. At 20 bucks a pop, it doesn't take very long to get to way too often. So I switched to the RCX 2206 motors, 2206, 2250 kV. So all of that together necessitated a bit of a retune. And I've done I've got it pretty close to a good tune. If you watch the multi-rotor racing video I posted to my channel recently, you see that's the tune that I'm on. It's still like not perfect, but it's pretty close and it's way flyable. So I thought I would share with you the postmortem that I'm doing on my tune after those races, uh, and just share with you some general thoughts and maybe provide some insights for people who are still trying to learn how to look at these logs. So the first thing I'm going to do, especially since I've changed my motors and my props, is I'm going to check the gyro traces. I've said before that with Betaflight, the gyro traces are often very, very good, but it's always worth going back and just having a quick look whenever you, especially with new motors and new props, which could change the vibration characteristics of the frame. And I'm going to do that by bringing up the gyro traces and zooming all the way out. And then I'm going to look at the thickness of the line, and the thicker the line, the noisier the axis is. And immediately something should jump out at you. The roll line is relatively thin, has a few places where it's a little noisy. The pitch line is very thin pretty much throughout. And that's normal because I'm flying, the frame is Red Rotor Strider Flex. It is a blackout style, H style mini quad frame. And on those frames, the weight is more centralized along the roll axis relative to the pitch axis where it's more spread out. And as a result, the pitch axis is more inherently damped. You would expect to see a little bit different if you were flying something like a Krieger or a Shrike, which is they call it a pure X frame, or even maybe something like an Impulse RC Alien, where the mass is more centralized along both axes. You would expect to see more of a uniform noise profile on pitch and roll. But it's quite normal in this case to see a little more noise on roll than on pitch. But we see a lot of noise on yaw. This is especially with Betaflight. This is a very noisy yaw axis. If we look right around here, that part is very thick and very noisy. Certainly we're gonna go and dig in and we'll look at the PIDs and stuff. But this definitely suggests that there may be a mechanical issue that is worth looking into. Run up the motors on the motors tab to see if any of them are out of balance. I would be surprised if the motors were out of balance because these motors, the RCX motors, come from the factory with motion balancing already done on them. They have a little bit of a like blue goop inside the bells where a machine has balanced them out. And so they come from the factory very well balanced by all accounts. But it's certainly worth a check. I could have crashed and got some dirt in a motor or something like that. And then the other thing I would certainly check is the props. These are the King Kong props, which are a budget prop, and they're a decent prop, at least on 5-inch for sure. If you follow my channel, you know I wasn't entirely happy with the 6-inch version. But it's certainly possible that they're coming from the factory not quite as well balanced as a high quality prop like, well, an HQ prop or something like that. So definitely want to go to the motors tab and spin up the motors without the props to check the balance, and spin up the motors with the props again to check the balance. I'm not going to do that here in the video. There's many resources. Maybe I'll do a video on how to do that, but there's many resources on how to do that. We definitely want to check that. Anytime you have excess noise, the tendency is to say, oh, well, I'm going to filter the noise out. And filtering is a good tool and a necessary tool. But the first thing you want to do is you want to try and remove the source of the noise if at all possible. Now, I don't advise balancing your props on multi-rotors. On mini quads. Mini quads, we are breaking props so often that I just don't think it makes sense to take the time to try and balance your props. Now, some pilots do it, and more power to them. Also, on mini quads, the small props we use, the smaller the prop, the higher the frequency of the vibration, and therefore the easier it is and more naturally it's filtered out, and the less relevant it is. So if you're flying a multi-rotor with 15-inch props, it's definitely worthwhile to spend a lot of time balancing them because your vibrations are going to be a lot more significant, and also you're probably not going to break props quite as often. But if you're flying a multi-rotor with 6-inch, 5-inch, or 4-inch props and a high KV setup, it's probably not worth your time. But looking at the motors, looking at the props to say, are these props just very out of balance from the factory and maybe it's not worth my time to fly them and maybe I should switch to a different prop? That's something that seems like it's you have to sort of say, is it worth my time to go to a more expensive prop or not, right? Okay, so fine, enough about that. I have a noisy yaw axis though, we'll keep that in mind. So then let's take a look. Well, I always like to start these days with the roll axis, and I will zoom back in 100%. And let's go to the beginning right here. And we'll just take a look at how much noise we've got. Now, there's two main things I'm looking at here right now. One is how active is the p-trace? If the p-trace is too active and starts to show signs of oscillation, I'm going to think about whether I need to reduce my p gain. The other thing I'm looking at is the d-trace proportional to the p-trace? We don't want to see scenarios where the d term is like hugely bigger than the p term and is sort of dominating the PID sum, which I don't have the PID sum up right now, but we want to see the d term be roughly proportional to, in size and movement, the p trace. Now, it's hard to tune the d term by looking at the black box traces alone. And so if you're doing flips and rolls and you're getting bounce back, you probably need more d. But just going off of what I'm seeing here, it feels like it gets me in the ballpark. And so far, nothing about this really feels too bad. As the throttle goes up, I start to see a little more regularity as opposed to sort of randomness in the oscillation or movement of the P trace, and the D trace, of course, goes with it. But that's kind of par for the course with the roll axis. Here, for example, this jumps out to me as starting to get maybe a little more active than I would prefer. If you compare this section here to maybe this section, you see there's movement here, but sometimes it's big and sometimes it's small, sometimes it's wide and sometimes it's thin. But as we get to here, we start to see a sort of a semi-regular peaking of the P and the D trace, more regularity, and that starts to look like maybe you're getting in the realm of excess P gain. Now, actually, I don't think this is excessive. I feel like this is pretty good. We'll keep looking at it. It flies good, and I don't think I'm going to lower the P gain here on roll. But if this started to get worse, maybe I would think about it. That's what I'm looking for. As compared to here, where it's kind of random, that's normal and not a problem at all. Let's keep looking. Now I'm going to go into a turn. Here we are going into a turn. Let me just play it for you. And let's see what happened during that turn. There's a lot going on there. Do I see oscillations? No, not really. I see the D term moving and working. It's active, but it doesn't feel like it's sort of slamming the PID sum all over the place. Overall, this feels pretty good. It might be slightly on the edge of too active, but that's okay. I don't think it's over the edge. I'm also looking at the gyro trace, and I'm looking for signs of oscillation in the gyro trace, and I'm not seeing it. No sort of back and forth waviness. It seems relatively clean. Yeah, looks pretty good. We got something here. We got a little dip here. What happened there? Let's take a look. We'll back up a little, and we'll go to 50% speed. Is that just where I pushed the stick? Yeah, I guess so. Let's bring up RC command. Yeah, I guess so. I guess I pushed the stick here and I got a sharp response. I'm not sure why it was such a sharp response. It wasn't a terribly sharp stick move. And you can see that the P term pushed into the move and then very quickly reversed itself. I don't know what was going on there. That's very interesting. I don't have a lot to say about it, though. Yep. Okay, so overall, I feel pretty happy with the roll axis here. Overall, I feel pretty happy. Any high throttle points? Not really. So let's take a look at pitch next. And we will scroll forward. Now, if we compare pitch to what we were seeing on roll, notice that the P term is a lot less active and more docile. And the same for the D term. Now, there's actually slightly more gain. I think I'm at about 4.2 on pitch P and something like 3.7 on roll P. So the P term is the pitch P is actually higher than roll P, and yet we see less activity there. It's more damped, if you will, due to the mass of the copter. The D term is a lot more docile, not really any signs of oscillation, and I might bump this P gain up just a bit because I would like to see it be a little more edgy than this, even when the throttle goes relatively high. Not really any signs of oscillation. It's moving, but it's not oscillating. Think about that distinction, if you will. This is kind of random movement back and forth as opposed to regular movement. Here's the first sign, maybe something that starts to look like an oscillation, but it's relatively low frequency and it's relatively soft in amplitude, so I'm not too concerned about that. I'm pretty happy with this. Yeah, so I might raise just a little bit. And then finally, let's go to yaw. Now, yaw is a different story. And as I said, the first step is to try and figure out the mechanical cause of the vibrations. But setting that aside, if we assume that that's a given, one of the things that Betaflight has, I think it has in its later versions, I'm running Betaflight V2, but I'm not on the latest rev. I tend to stick with the firmware I've got until there's a compelling reason to upgrade, and this may be it. It has a separate P-term filter for yaw, I believe. And this really demonstrates the necessity of that because we have a ton of P-term movement and with it D-term movement. Even though my P gain and D gain are not particularly high, I believe I've got a P gain of 10, which is a little high, but on yaw, I've seen it much higher. And a D gain of, I think, 10, which is nothing for D gain. And yet there's a ton of movement here, and that's because there's a ton of oscillation in the gyro. So if we can't get rid of that mechanical oscillation and clean up the gyro trace, then the next thing to do is to add some filtering on the yaw axis, just the yaw axis though, and hopefully that'll be a little better. So I probably am going to lower the P gain here just a bit, and maybe the D gain as well, just because for the time being this is a lot of movement. And I bet where this is coming through in the motor traces as well. A little hard to tell because, of course, there's a lot going on here. But there's a lot of movement here, and that's more than I would like to see in an optimal condition. So I'm going to do what I can to get rid of that. That's not good. All right, well, I hope that's helpful. And as always, happy flying.